Benchmark 1 says, I shoot an arrow with an initial velocity of 95.0 meters per second at an angle of 36.5 degrees. How far away from the target do I have to be to hit it? So, in this problem, we're going to use the Xmax formula to be able to calculate the distance or the displacement in x. So we're going to use the VI, that in this case will be 95.0 meters per second, and we're going to square it. Then we're going to multiply this by the sine of theta, that in this case is 36.5. And then we're going to multiply this by the cosine of theta, that is 36.5. So then we're going to divide all of this by 9.8 and multiply by 2, which is going to give us that delta x. That will be the how far away the person will be from the target. So this calculator works by using formulas like Xmax and also formulas like the Big Four, and by calculating the variables from the x-axis and the y-axis. So it will calculate time and delta x as well. So in this problem, delta x will be 880.6 meters. Benchmark 2 says, I shoot a compound bow with a velocity of 125 meters per second at an angle of 15 degrees. How far away from the target must I stand, and how long will it take for my arrow to hit the target? So in this word problem, we're trying to find the delta x and also time. So first we're going to use Xmax with the variables we already know, that are VI, theta, and gravity, to find the delta x, that in this case will be 797.1 meters. And then we're going to use the same information to find time, that will be 6.6 seconds. Benchmark 3 says, instead of shooting an arrow on Earth, I'm shooting the arrow on the Moon. The Moon has a gravity of 1.620. Can you tweak your model so that you can solve either benchmark 1 or 2 with the new information? We chose to solve benchmark 1 with the new information. So we will have a VI of 95, a theta of 36.5, and a gravity of 1.62. Then we're going to use the Xmax formula to find out delta x. And in this case, delta x will be 5,327.6 meters. Benchmark 4 says, I kick a soccer ball at a 25 meter per second of a two-story building, about 10 meters, at an angle of 67 degrees. How far away from the edge of the building do I need to be to hit the target 30 meters away from the building? So we're going to plug in VI, theta, and gravity, and then we're going to get a VIX that will be 9.7, followed by a time that will be 4.7, and a delta x that will be 45.8. Benchmark 5 says, Baltoy shoots his hydrocannon with an impressive velocity of 500 meters per second. If his opponent is standing on a cliff 50 meters above him, that is 100 meters away, and he's aiming at a 58 degrees above horizontal, then how long will it take his shot to hit his opponent? After plugging in VI, that will be 500, theta, that will be 58, and gravity, that will be 9.8, and delta Y, that will be 50, we're going to get that the time needed to hit the target will be 0.1 second. The extra problem says, imagine you run and jump off of a 12-meter waterfall, and you jump at a 15 degrees with a velocity of 7 meters per second. How far from the waterfall will you land, and how long will you be in the air for? So first we have the variables vi, that will be 7, theta, that will be 15, gravity, that will be 9.8, and delta y, that will be negative 12, since you're jumping off a 12-meter waterfall. Then we're going to use this information to gather time and delta x. Time will be 1.7 seconds and delta x will be 11.9 meters.